factor.
So what I wanted to do first, yeah, like you say, I wanted to check that you can do fractions as numbers first. Because the thing with algebra, I think I've said before, is what you can do with numbers you can do with algebra. If you can't do it with numbers, you can't do it with algebra. Simple as that. So for instance, if we were to say 2 over 3, so obviously it's not algebraic, times 6 over 8.
Oh, no, you can't do that.
What do you have to say the denominator?
You make common denominators. 6 and 3.
Oh, so
you
you
teach
teach
me how to do fractions.
I guess.
No idea. I'm pretty sure it's...
So what I would say here, what I would probably hope at this stage you would know, but I understand if you don't, is a couple of things. Basically how to do it, but also how to simplify. Okay? Now I would say, can you simplify before the calculation?
Yes. Yeah, that 6 over 8 can turn to 3 over 4.
Okay? So we could simplify this one, and what's it called? We are doing an
Equivalent fraction.
okay, so we're looking at equivalent fractions there. So we can change it already to 2 over 3 times
3 over 4.
So what we need to do, however, is not just do it, but understand why we can do it. What is the reasoning for that? And do you know that? Do you know about equivalent fractions and why you're allowed to do it?
Yeah.
Some people do, some people don't. Okay, well, let's have a quick look then. If we have a look at 6 over 8, what's the mathematics behind it being the same as 3 over 4? But why? Okay, so I like the common factor thing you say. So this is probably quite important that you understand it when you try and do algebraic fractions, because we could write this as, like Yasmin said, about common factors. So we look for common factors. So if I said it's 2 times 3 all over 2 times 4. Okay? That's fine, isn't it? Makes sense. 2 times 3 is 6, 2 times 4 is 8. So I've taken the 2. Okay, so you've now said that you see that 2 and 2 cancel each other out. But I guess what I would like to do is, what do you mean by cancel each other out? What actually happens?
2 divided by 2 is 1. And then
Good.
1 times 3 is...
There you go. So I would say, some people say when they say cancel out, oh, you just cross them out and they disappear. Poof, magic, they just go. Yeah? But actually the maths behind it is that when you multiply things like this, I could now actually write this as 2 over 2 times 3 over 4. I can split it like that. And then 2 over 2 is actually 1. So I've got 1 times 3 over 4, which is 3 over 4. Okay? So it's not that they just magically poof and disappear and they're gone, and we know that it's 1. But why don't we write the 1? Because 1 times is...
It's not the same thing.
Yeah, just gives you the same answer. How?
8. Can't you make the denominator just the same? So you times 8 by 3 and 6 by 3 and then
We can, but why would you want to? Why would that make it easier? I think what you're doing is you're confusing adding and subtracting with multiplying. Because we haven't got an answer yet, but well, let's talk about this. Yeah, what you're referring to is the adding fractions. When you multiply something, we're looking for 2/3 of 3/4 now. Does that make sense as well? If I say it's 2/3 of 3/4?
Yeah.
Because that's what multiply means. Now, before we do that though, is there any further simplification that can be done before we do the calculation? No?
If you divide by a decimal instead.
So decimals are, oh no,
2 over 4.
we can, but we don't want to. Just because 2/3 is a horrible decimal.
I think it's 6.
What about this? What about this? Multiplication of the fractions, what do we actually do when we multiply fractions?
We add.
Don't you do cross multiply?
Don't you?
I thought that you
divide
multiplied
the
it.
divide
Do you know what I'm seeing here? I'm seeing all the common misconceptions all piling in at once, because basically what you've got is you've been given a lot of tools and less understanding. Okay, I don't mean to be mean. I'm just kind of you are normal in that lots of people say cross things, whatever, because it is something that you can do, but it's like, why do you do it? What's the reason for it? Can you understand why you're allowed to do it? And then if you do, you'll go, I know when to do it. So at the moment you're telling me to do things which all are valid, but they're not done, it's not necessary, or it's not the right thing at the wrong, you know, so we're looking at why are you doing what you're doing. And if we can get that sorted with numbers, then when it comes to algebra, it'll make sense. If I try and go straight into the hard algebra stuff, you'll be like, no idea now. Right? So what I'm going to do is this. When you multiply fractions, you just multiply the tops and bottoms. Okay? So you do 2 times the 3 and 3 times the 4. But really we should look into why, but this is the simple case. When you multiply fractions, you just multiply the tops, multiply bottoms. Now instead of doing that, I'm going to do this now. I'm going to write it's 2 times 3 over 3 times 4. Happy with that?
So 6 over 12? Is that half?
It would be 6 over 12. But I'm still looking at, can I simplify any further? Now you might say,
Yes.
don't need to, but right? But before we do the calculation, so I'm trying to explain to you cross cancellation.
Oh.
And the reason why is because multiplication can be written in either order, yeah? So what if I go from here and I do 3 times 2 over 3 times 4? So now we're in the same situation we were here. So we end up with 2 over 4. Okay? Now, what you may notice it as is, oh, before I multiply, why don't I cancel this 3 with this 3? Cross cancelling. So I can cancel the 3 and the 3 and it becomes a 1 and a 1, which is what happened here. It becomes a 1 over a 1, or 1. And then actually I do 2 times 1 and 1 times 4, which is 2 over 4. However, you might now say to me, oh, but there's another cancellation I could do before I do it, which is?
You could divide.
What about the 2 and the 4? Can I do anything there?
Yes, you could divide them by 2.
So the 2 and the 4 will go down to 1 and 2. So now I've got 1 times 1 and 1 times 2.
2. Wow. But that's
So I've got the answer without actually doing the calculation, just by simplifying. But yeah, we get there anyway. But this is a nice simple one to do. Going through all these little methods that you've probably gone through in the past. Okay. Alright. So this is what you may have remember being called cross cancellation. Now the problem with calling it cross cancellation is you think it has to be cross cancellation, but it doesn't. It's basically saying anything on the top can be cancelled with anything on the bottom. So maybe we ought to write that. So anything on the top can be cancelled by anything on the bottom. Now I could use proper mathematical terms here and say, so any can be cancelled by the denominator. That would be a better way of saying it. Okay. Now that can be in the same fraction like we did it to start with. You know, we've done it both here, haven't we, in this question? So 6 and 8 were cancelled first. That's not cross, still cancelled, that's called equivalent fractions. But then we did the cross cancelling twice. But but you're seeing why it can be done now, purely because the multiplication can be done in any order. Okay. Now, I've got a question for you though. Why is 2/3 of 3/4 a half? I'm going to let you think about it.
What's the question?
So why? So if I just, can I rewrite that? Are you writing your notes? Could you explain why is 2/3 times 3/4 a half?
Because
I actually think of it in pizza, if you like. Have a think, discuss it with each other. I would like you to understand, rather than just be numbers, why is 2/3 times 3/4 a half, and the times is what word? Of. So think of it in that way. Okay? So try and think. I'm going to pause and give you a couple of minutes to think it through. Can you explain to someone, and I'll tell you, I'll give you out these boards. I don't know, we've got enough actually. Have a think. Could you explain to someone, actually explain how physically 2/3 of 3/4 is a half?
Can we get the question?
Okay, so what I would like to do, the first thing, I think doing 2/3 of 3/4 is easy. Now, what a few of you did, which makes it hard to understand, is think I've got to draw a diagram for 2/3 and a diagram for 3/4. However, if I said show 2 times 3 as a diagram, you wouldn't do a 2 and a 3, right? If I say that, how would you show 2 times 3? I would do, there is a 3, and then do it twice.
Yeah.
I wouldn't do it as a 2 and then a 3 and try and explain it. Does it make sense? Right? So in the same way that doing 2/3 of 3/4, if you draw 2/3 and then 3/4 and try and stick them together, it's going to be hard to understand. However, if I think of it as 2/3 of 3/4, that means I start with 3/4 and I want 2/3 of it. So the yellow, I've set up my 3/4, I've forgot the other quarter, but still there. But now the 3/4 becomes my whole, everything I've got. And I've got to do 2/3 of it. So my 3/4 needs to be split into how many pieces?
3.
3.
Oh, and it's 3/4. Oh.
I've got 1, 2, 3 pieces to make 3/4.
And then 2 of them.
But I need 2 of them. So if I keep 2 and get rid of the third one, how much do I end up with?
Half.
A half. So 2/3 of 3/4 is
1/2.
a half. So it makes sense. However, let's think of it the other way around then. What about 3/4 of 2/3? Slightly more difficult to visualise, isn't it? So I'm going to try and draw in thirds. Alright? And I've got 2/3 of it. Right. So this thing, how do we, so we've got to split 2/3 into how many pieces to start with? 4. Because I need it split into 4 and take 2 of them. So what we have to do then is think, to get 4 pieces in total, I've got to split each one into 2. Okay? So how much is each piece now? If they're thirds, and now I split thirds into 2 pieces, each one's a 6th. Now, I need 3 of those 4 pieces, 1, 2, 3,
You had 3 6.
No, you didn't.
and it's the half again.
I legit just said regular.
Alright?
Y'all loud.
So, that's why when you do, you don't see that? No? So I've split my 2/3, okay, to the yellow bits, into 4 pieces. 1/6, 1/6, 1/6, 1/6. Okay? If I want 3 out of those 4 pieces, 1 6, 2 6, 3 6,
It's a half. I got
is a half. Okay? So that's how you can explain why multiplying fractions, why it works. It's exactly the same as multiplying whole numbers. So I guess that leads me to something for you to work out. Does anyone remember how to do
Yes, you flipped the fractions. I remember that.
okay,
when
So-
the times them.
dividing? So what would you say? Step 1, find, I don't like the word flip, but find the, what was it called?
Opposite.
Reciprocal of the, I'm going to call it the divisor, the thing that you divide by, okay? Then multiply. So we would do, the actual calculation would be 2/3 times 4/1. Okay? Alright, make sense? So 4/1 is, well, it's the same as 4. But what would the answer then be? Can we simplify here first? Anything on the top can be simplified by anything on the bottom, so 3 with 2, 3. Doesn't look like it, no? No common factor there. So what do we end up with then? We end up with 8/3. Okay. Which as a mixed number would be?
2 over.
I mean
2 over. 2 and
3rd.
2/3.
Okay. Now, what's coming next is this. Can you explain that with diagrams?
Why didn't you diagram? That's a mixed number. Wait, no. What do you? Which one?
Because when you divide, you only flip the second fraction, the divisor. The divisor is the thing that you're dividing by. Now, what I would like to consider, you know, like we've just done with the multiplication, I would like you to think of and see whether you can explain why that works. What does it actually mean to do 2/3 divided by a quarter? Visualize it, because otherwise it's just numbers happening. But what does it look like visually? So, the way we started before was to think, what does dividing by mean? So 2/3 divided by 4 means, I would say, how many quarters in 2/3? Yeah? So could you, again using your whiteboards, could you explain that? Could you think of a diagram that would show why the answer is 2 and 2/3? Might be a hard one to do, but try and explain why. And maybe it will then help you realise why the number gets bigger. How many quarters are there in 2/3? Right, just to show you, I'm not going to do the answer, but again, just to show you, let's say I was going to do 8 divided by 2. Again, if I do 1, 2, 3, 4, 5, 6, 7, 8. If I do 8 divided by 2, I don't do this. I don't do 8 divided by 2 and go, right, what do I do now? It's not the way you do it, is it?
No.
Right? You have one diagram of 8 and you split it
Into groups of 2.
either into groups of 2 or into 2 groups. Either way. The way we're looking at it is how many quarters and 2/3, so we could say how many 2's in 8. So we would split it. How many 2's in 8? So the answer is 4. So what we're looking for is we have a diagram which is thirds. I only need how many of them? 2. Okay, so if I consider 2 of those thirds, but what am I now trying to work out? How many quarters? So what do I need to draw on my diagram? Quarters, and how do I do it?
Down.
Take the whole diagram and split it into 4.
Nikolai, that looks wrong.
That's exactly what I
So, how many quarters take up the same space as 2/3?
I do each part.
1, 2, and then
2/3.
2/3.
Divide. Oh. See, you guys,
That's what
you guys said. That's wrong.
So,
Doesn't need to chill. Why not? So we know these.
That's what I drew, like yellow.
That is what I said. I parted it into 4 parts. But you was like, look, let me take this book. How you erase my mouth.
But you would have tried one.
would you like me to?
Yes.
I don't for you. Okay.
Let's see her.
I would like you to explain. What should we say? I'll do an easier one for you. 1 and 3/8 divided by 3/4.
Okay, so can we turn the next It's something over 8.
You have one.
Okay, so I'm not telling you the answer by any means. I'm just starting off. I'm showing you. I've got 2 circles. Each circle is split into 8s. I've got 1 and 3/8. So the 3/8 on the side. So actually, my 3/4, we can ignore the white one. So we've got to look at that and figure how many lots of 3/4 fits in that. So, do you want a bit longer to think it through? Or should we do it?
No, I think we got it.
You got it? So, what I would say then is, if I was going to do this, how many lots of 3/4? So, basically out of this one, 3/4 is that. So that's 3/4. So there's 1 full 3/4. But then I've got 1/4, 2/4. That's not enough yet. So if I think about it, I've got 1 lot of 3/4. But then I've got 1, 2, I've only got 3/4 of. No, sorry, was it 2/3 of 3/4? 2/3, because 1, 2 out of 3/4, so 2/3 of 3/4. And then how much is that of 3/4?
That's an 8.
So out of 3/4, it would be 1, 2, 3, 4, 5, 6, 1/6 of 3/4.
So it's 5 and 1/6.
1/6 of 3/4. So we would have. Diane, what do you think it is?
5 and 1/6.
So 2/3 of 3/4 is the same as 4/6 of 3/4. So 1/6. So 1 and 5, 6.
You're way off.
I always love the number.
Yeah. Yes.
Excuse me, we got that.
5 and 1.
Yeah, you got that? Now we can check by doing one and how would we do this? Just number wise. So we would do what you did, I think, which is 1 and 3/8 gets changed to 11 over 8 divided by 3/4. But then we flip the second fraction. So we do 11 over 8 times 4 over 3.
44.
So what, does anything simplify?
No. Yes, it could be.
Anything on the top, anything on the bottom. So the 4. So 4 will go to 1 and 2.
That's 11 over 3.
So we've got 11 times 1 is 11 over 6, which is 1 and
5.
Well done, Libra.
okay. All right.
Can you chuck another one at us?
Do you want another one?
Yes, please. I'm not completely understanding.
Well, what I would say is, let me just qualify what you're doing now. You will never have to do this for an exam or anything. You just have to do this bit. This bit in the exam. You have to remember to multiply. The only reason I'm doing this is I'm trying to get you a better visualization of what actually is happening. I think a lot of people with fractions don't really get what dividing by a fraction actually means. It means the same thing as dividing by a whole number, which is why people sometimes get confused. It's like 1 divided by a quarter, you should easily see now is how many quarters in 1? How many quarters in 1? 4. Right? 1 divided by a quarter, how many quarters in 1? 4. Now some people go, but it's got bigger, and dividing always gets smaller. So that's why. So for instance, you should be able to do very quickly now. What's 3 divided by a fifth?
3.
3 divided by a fifth. Now you should, if you're visualizing it very clearly now, be able to give me the answer very quickly. But maybe you would, I'll tell you what, I'll make it easier for you to draw on your diagram. Let's do 3 divided by a sixth. How would you show that on your diagram?
So,
I make the diagram out of 6.
we're doing 3 different circles. Right?
So 3 different circles. Do you want to talk this through or do it yourself?
Talk it through.
You need 6.
Talk it through? Do it yourself? Do it yourself. Someone wants to do it themselves.
You do 3 circles. It's this.
So, again, 3 divided by 6. If you were just going to do the maths, okay, you're just going to do the maths, you would do 3 times 6 over 1. Now, just to you hopefully now will understand the flipping the fraction upside down, because 3 times 6, well that is because you would have noticed if you draw, you were drawing your 3 circles. I'm only going to do 1 because they're all the same, and you split your circle into 6 parts, okay? Okay? And you notice that each one has how many sixths? 6. That's what sixths are, right? There are 6 lots of a sixth in a whole one. Therefore, 3 split into 6 makes sense that there will be 3 lots of 6.
Yeah.
So that's why it makes sense to flip the second fraction upside down. So we end up with 18. Alright? That makes sense? So 5 divided by quarters. Well, that's because you know you've got 5 lots of how many quarters in 1? 4. So the answer is 20. So when you start thinking of division, even by a fraction, as actually division, it makes more sense. Alright? Okay. So for the last, let's move on. So we've done division and multiplication. How are you with that? Does that, you recap things you've done before, yeah?
Yep.
Just to check one thing then. So let's say 5/16 times 4/30. I want the answer to that. I want it simplified before you do the question. Because let's say it's a non-calculator question and you've got to do 16 times 4.
So we could do.
Can I, before I get you to give me the answer, can I let everyone have a think it through, do it on your board, do it in your book? Sasha?
Or you can hold it.
Girls, we're ready. We've got someone who's going to explain. Go on, what cancels with what?
Okay, so 5 goes into 36 times. So you
Oh,
so
that's
5
right.
plus 1.
So 1 and 6.
And then 4 goes into 16 4 times. So 1 and 4.
Yeah. And then we just do 1 times 1 is
1,
4 times 6 is.
24.
And then we have it. Our answer. And just to say, this is in simplest form. Okay? Now, just to check, what about if we have our calculators? Do you all know how to put your fractions and do it? So all of this, by the way, is useful when you have non-calculators. Now, I will say all the way through this course, you are much, much better to work in fractions than you are with decimals. Because you can see how, when you work in fractions, really, the biggest numbers you've got to multiply by are like 1s and 9s and things like that. You very rarely have to do big numbers, right? Decimals, it just gets silly. So you do have a non-calculator paper to do. Therefore, getting used to using fractions. Right, what about though, let's think about adding and subtracting though. Adding and subtracting fractions. So for instance, 5/4 plus 3/5.
Isn't it when you add you multiply?
But why, I guess? Who knows how to do it already?
I do. You do.
Hang on, I've got lots of people talking at the same time and I'm not getting anything. Hand up, okay, go for it.
Like denominators.
Okay, so I guess if we're writing notes out, stop me if you want to write stuff out, we're doing stuff on the board. But when you add and subtract fractions, and this again is really important for algebraic fractions because we do it with numbers, we do it with algebra. So we need to find a common denominator. And we do that by actually finding the lowest common multiple. Okay? So we do it by finding that. Now, a lot of people, when they find the lowest, when they find a common denominator, they don't find the lowest common multiple, they just find the easiest common multiple. And I don't think that's an easier. You can simplify it. But just to say what we could aim to do is to always find the lowest common multiple. Now, in the example I've given you, actually the lowest common multiple is the easiest common multiple as well, isn't it?
Yep.
All right. But can you? So before we do it, before I ask you to explain, let's do it. All right. So do you know what the answer will be? So, because what I would do, I would like you to understand and explain why, if you can, we find the lowest common multiple. Why do we do it? So, what does this first one have to become?
13/20.
So we have to go 20 and 20, and there is the lowest common multiple. Lowest common multiple of 4 and 5 is 20. We all agree?
Yep.
Okay. Now, to find equivalent fractions, we do the same to the top as the bottom. Do you know why?
So it
Even.
But
Makes
what?
sense.
That makes sense, does it? Okay.
Because when you change one, you have to change the other because
But why?
you
Yeah.
keep the fractions the same.
But why does it? Is my question. So, for instance, you're going to tell me multiply by 5. Therefore, you have to multiply by 5. So we get
25.
25 over 20. And this one has to be multiplied by 4. Multiplied by 4. So we get 12. Okay. So then the answer is 37 over 20. Okay.
Good job.
Good job.
That's it. We don't
She's like, "Wait, you did that."
She got 8 over 9. She had one that was more than 1 to start with, added something to it, and got less than 1 at the end. It's fun. Now, what I would like, actually, is to understand this, again, because it's going to work for algebraic fractions, to understand the equivalent fraction, I would like you to try and explain if you can, but we'll do it with a simpler one. Could you do it by drawing a diagram? Can you explain why 2/3 is the same as 4/6? So could you do it on your whiteboard? Explain it to me. Can you show why 2/3 is the same as 4/6? And hang on. And explain why that's because we times 2 on the bottom and times 2 on the top. Where does that come from? Why times 2 top and bottom?
Is it because 2 goes into
I think, and then tell me in a sec. Okay? Right, back with me? You girls still thinking it through?
No, we got it.
You got it?
Yeah, we
Okay,
got
so
it.
on my diagram, I've drawn a diagram which is 2/3. So remember, what I'm asking for is not just to show they are the same, but to show me why timesing the top and bottom gives me the same fraction. Why does it? And who would like to explain? No? Go on then.
Go on then, boy.
No? Leah.
I said, well, I would.
So you will. No one wants to explain that bit.
Because
Well-
it's consistency. Good 25.
Right, again, what you're doing for me, you know it, but what you can't do is explain why. So you've been told, which is perfectly fine, times the top and bottom by the same. I'm just asking, do you know why?
Because you have to keep it the same fraction.
But why does it do that?
If you like just multiply the bottom, it's not going to be the same fraction, so you have to keep it the same.
No, so that is the same number.
As one increases, the other has to increase as well.
But why?
If you times something, that's how math works. If you times something by 2, it's the same
Because I see it.
Okay, right. Now we start to think of it a little bit more. So basically, if we think of what we do, let's think of, remember when we add for fractions, which is the first number we look at changing? The numerator or the denominator? The denominator. The denominator is the size of the fraction. The bigger the number, the smaller the fraction. So if I change the 3 to a 6, I'm basically halving the size of my fraction. So I'm actually saying I now need 6 pieces. Alright? So I've halved the size, but when you halve the size, if you need to keep the same number, you have to have double the amount. So this is probably the one bit you haven't quite realised, is if you multiply a fraction by 2 on the denominator, you are halving the size of the fraction. Therefore, you need twice as many of them to keep the same amount. Alright? So by making the bottom a 6, I'm halving the size of the fraction. So the top has to be doubled to have double of it. Okay? We'll carry on working on it. There'll be more algebraic next time.